Oh, hello there. My name is Jake Olszewski, and I will be teaching you Chapter 5.5, Trapezoidal Rule. Now, we learned in an earlier chapter, 5.1, that we can use MRAM, LRAM, and RRAM to calculate area underneath the curve. Now, is there a better way to calculate it than with rectangles? Trapezoids. They're more accurate, they help solve the problem better. Now, trapezoidal rule goes delta x over 2, parentheses, times the initial value plus 2 times y of 1 plus 2 times y of 2 plus 2 times y of 3, etc., as far as it goes up, plus 2 times y n minus 1 plus just a solo y of n, just like the first one was y of 0. Now, this rule can be applied to fairly simple problems that will help you understand trapezoidal rule as a whole, such as this one, integral of 1 to 5, 1 plus x squared dx, where n equals 4. Now the graph looks a little something like this. It is a parabola starting at 1. You have 1, 5, and the other numbers in between. 1, 2, 3, 4, 5. Now to find the delta x over 2, you take the difference between 1 and 5, 4, put it over your n value, 4 over 2 equals 1/2. And then you just quite simply plug everything in to the earlier equation. Now you start off 1/2 times 2, your initial value, plus 2f2 plus 2f3 plus 2f4 plus f5. Right? And there you go. And from there on out, you quite simply just take the 2 from this and plug it in to 1 plus x squared. So you get 1 over 2 times 2 plus 2 times, when you plug 2 in, you get 4 plus 1 is 5. And you do it the rest of the way out. So it ends up being 2 times 10 plus 2 times 17 plus 26. And then from there on out, it's a basic arithmetic equation. You just multiply everything and add everything together. So you get 1/2 of 10 plus 20 is 30, plus 34 plus 26, 60, plus 2 is 92. And that comes to be 46. That is how you find the area underneath the curve from 1 to 5. Now, that is a basic equation that will help you find any other equation using the trapezoidal rule. And this rule can be applied to many other equations like this next more difficult one. Okay, now this is a much more difficult problem dealing with trapezoidal rule. Now we have y equals x squared plus 4x plus 2. The interval 0 to 2, or n equals 12. I've already found that delta x over 2 equals 1/12. Now, to find the numbers to plug into your equation, let's first go to your calculator. Type into y equals x squared plus 4x plus 2. Hit graph. And the graph should look like this. Parabola. Then, second, table. Go to your table. You're going to need to adjust it so that you're seeing from 0 to 2. So, second table set it at 0 and 1/6. And then go look at your table. Then just plug in the numbers as it goes, like so. 1/12 times 2 plus... Okay, so 2 plus 2 times 2.6944 plus 2 times 3.44. I'm just going to round it to 2 decimal places from here on out. So I'll change this one to only 2 decimal places. Plus 2 times 4.25 plus 2 times 5.11 plus 2 times 6.03 plus 2 times 7 plus 2 times 8.03 plus 2 times 9.11 plus 2 times 10.25 plus 2 times 11.44 plus 2 times 12.69 plus 2, oh, my mistake, plus 14. And then, once you get through that, you just once again multiply them together, add them up, and then once you get that, you get so it comes to 1/12 of 2 plus 5.38 plus 6.9 plus 8.5 plus 10.22 plus 12.05 plus 14 plus 16.056 plus 18.22 plus 20.5 plus 22.89 plus 25.38 plus 14, and then simply calculate that up. It's 2 plus 5.38 plus 6.9 plus 8.5 plus 10.22 plus 12.05 plus 14 plus 16.056 plus 18.22 plus 20.5 plus 22.89 plus 25.38 plus 14 equals 176.096, and then multiply by 1/12 and you get 14.67. That ends up being your final answer for the area underneath the curve. Now, that is a much more difficult problem than the first. Yet another example of trapezoidal rule for you to use in understanding trapezoidal rule. And now, from those two example problems and my excellent teaching, you have the basic understanding of trapezoidal rule. And with that knowledge, you can apply it to any problem. It's just a simple formula. Once it is memorized and the steps are memorized, you can apply it to any problem dealing with the area under a curve. So, I'll leave you with this. trapezoidal rule formula. Not as intimidating as it sounds. You have a good day, Audubon. Stay classy.